All right, 5.5, linearization and differentials. So linearization, if f is differentiable at x is equal to a, then the equation of the tangent line L of x equal to f of a plus f prime of a times x minus a defines the linearization of f at a, the approximation f of x is approximately equal to L of x is the standard linear approximation of f at a, the point x equals a is the center of the approximation There might be some down there, I'm not sure. Sometimes people leave the box empty, so.
If there is, can I get, it's 2 for $1, right?
Yeah. So with this stuff, I'm just gonna do like notes as we go because there's only like one thing. Yeah, that's fine. One thing like that goes with like a certain set of problems, and then there's like one other little thing, and then anyways. So this section just makes more sense to go ahead and just do it as we go. So looking at problems. For 1 through 6, it says find the linearization L of x of f of x at x is equal to a, and then how accurate is the approximation L of a plus 0.1 approximately equal to a plus f of a plus 0.1. See the comparison, blah, blah, blah. Okay. So, not hard, just have a lot of steps to them. So, number 2, f of x is equal to the square root of x squared plus 9, and we're told that a is equal to negative 4. Okay, when we get to the derivative, we'll think of this as x squared plus 9 to the 1/2, but we're not quite there yet. So first of all, we want to find f of a. So basically, we're going to try to find each of these pieces up here, and then we're going to combine everything together. Yep, so we're going to do f of a, which is f of negative 4, which would be negative 4 squared, which is 16 plus 9. So that's going to be the square root of 25, which is 5. So that means at negative 4, it's equal to 5. So f of a is going to be 5. Now we need to take the derivative. So f prime of a, I want to take the derivative of this f of x equation first. So what is that?
Half x squared plus 9 times 2x. Oh, to the negative half.
Yeah. So that's my derivative. If I wanted to rewrite it, I can rewrite this. The 2's would cancel, so I'd be left with x over the square root of x squared plus 9. So then now, evaluate it at negative 4, because that's the second part here. I would have negative 4 over, again, that's the square root of 25, so negative 4 over 5. Okay, which we can call this m, which is our slope. All right, so now we actually have all the pieces. I'm going to put together this L of x equation. So L of x is equal to f of a, which is 5, plus f prime of a, which is negative 4/5 times x minus a, so that's going to be x minus negative 4, so x plus 4. So then this is equal to negative 4/5 x I'm going to, well, minus 16/5, and then I'm going to make this 5 be over 5, so plus 25 over 5. So then that's going to simplify to be that L of x is equal to negative 4/5 x plus 9/5. So this is part A. So part B then says to figure out how accurate the approximation is by doing L of a plus 0.1 and f of a plus 0.1. So a plus 0.1 is going to be negative 4 plus 0.1, which is negative 3.9. So this is the new value that we're using, plugging stuff in. So this is going to be my x value going in. So I'm going to check it. L of x is equal to negative 4/5 times negative 3.9 plus 9/5. And then you'll need to put that in your calculator to check it. Or to see what that's equal to. It was told to use 0.1 for the approximation. you get an answer for that? What is it?
4.92.
4.92. Did you round, or was that the actual answer?
Is the actual answer.
Okay. You'll see why I'm asking that in just a second. Okay, so then we're also going to do f of this negative 3.9 because it wants us to compare the two things. So this is going to be the square root of negative 3.9 squared plus 9. And don't round this answer. Is it nice outside? Don't round it. Eight four.
Oh, yeah, 6, 5, 8, 4. 6, 5, 8, 4.
Okay. So now what we're gonna do to figure out the difference, okay? We do this number minus this number. So 4.92036584 minus 4.92.
Go around this one.
Just, yeah, 2 decimal places is fine.
3.66 times 10 to the negative 4.
Okay, so the only part that I really care about is this. Okay, this is telling us how different, basically, our answers are. It's going to tell us our error. Okay, so for this particular one, our error is less than 10 to the negative 3. Okay, we always drop it 1 from whatever we get. Okay, so it was 10 to the negative 4, so our error is less than 10 to the negative 3 difference.
Wait, our error is less than 10 to the negative 3.
Yeah,
Why wouldn't it be?
because we always drop it 1, because that's the difference in the error.
So we always drop 1.
Yes.
So like if it was 10 to the 5th, it'd be 10 to the 4th.
Right, but they're typically going to be negative numbers. It's going to be like negative 4, so you drop it to negative 3. Because if you have an error of 10 to the 4th, there's something greatly wrong with that.
Yes. I'm just saying, hypothetically speaking, if I get a positive number, I wasn't sure if the numbers would flip it badly.
Okay, so let's do another one of these ones. A little bit different. F of x is equal to ln of x plus 1. And we're going to do it for a is equal to 0. So, first of all, we evaluated a. So, f of a is f of 0, which is the ln of 0 plus 1. So, the ln of 1, which is equal to what? Nope.
0.
Because e to the what gives you 1?
I don't know how it works. I was gonna say 0, but then I was like, there's no way that's right. So then I said 1, and I was wrong.
So what's the derivative of the ln of x plus 1? Just 1 over something.
It is 1 over something. Is this 1 over x?
Nope. Not in this case. If it was just the ln of x, it would be 1 over x.
X plus
1 over x plus 1. Okay. Technically, it's a chain rule, so the derivative of x plus 1 is just 1, so we don't have to write it. So then, evaluated at 0, we get 1 over 1, which is equal to 1.
Oh, wait. Are we taking the derivative
We were
of the original equation?
of this.
Oh, okay.
The derivative of this is, well, it's just a number, so it would have been 0.
Okay. Well, that's I guess I was, yeah. I don't, yeah. I was definitely thinking you're taking the derivative of just ln 1.
So then we can write our L of x equation. So it's f of a, which was 0, plus f prime of a was 1 times x minus a, so x minus 0. So in reality, L of x is just equal to x. So then we do, it says, so that, again, that's part A. Part B, we do it for, it officially says, just so you have it, a plus 0.1 approximately equal to f of a plus 0.1. Okay, so we're evaluating both of those at a plus 0.1, meaning in this scenario, a was 0, so it's just going to be 0.1. So x is equal to 0.1 for this one. So f of 0.1 is equal to L of 0.1 is what they want us to show.
What was that on the right side?
The right side, this is just what they tell you in problem B.
Oh.
It tells you to show that, basically, in
Oh,
short
basis.
terms. This is just, yeah, the instructions. So f of 0.1 or well, yeah. F of 0.1 is going to be the ln of 1.1 equal to L of 0.1 is just equal to I have that right. Wouldn't that just be 0.1? Yeah, it is. Okay. Never mind. We're good. I just can't read my paper, apparently. Because it just is being plugged into this equation here, yeah. Yeah. So then now I'm working my way down. So I'm doing the F stuff on the left side and the L stuff on the right side. So then what is the ln of 1.1?
1 over x plus 1.1? Oh,
No, like not the derivative. Like just, I think that's what you were just trying to tell me. I just need ln of 1.1. It's not far from 0, but it's not 0. And don't round.
Oh, no. Is it 0.953, 101, 790?
0.9 or 0.09?
0.09.
Okay. We'll just go out to there because that'll give us what we need. All right, so then now we do L of 0.1 minus F of 0.1. So that's going to be 0.1 minus 0.0953. And that's equal to what? In scientific notation, I should say.
4.7 times 10 to the negative 30.
So what does that mean about my error? It's less than what?
2. Negative 2. Is it 2 or is it 10 to the negative?
Okay, so my error is less than 10 to the negative 2 for this problem.
Why do we take 1 off the top?
I'm not 100% sure why. You just do. If I'm being completely honest. You just take 1 off. Basically, it's just saying that your error can't be all the way up to the value that you got. So your error has to be like a little bit less than that, basically.
Is it always going to be L of x minus F of x?
Yeah. And it's technically speaking the absolute value of that. So it doesn't really matter which one you do first. The number would come out the same. You just can't have a negative. So, yeah. That's one of those things where they don't actually ever write that that's what you're supposed to do. They just show it to you in examples in the book. So, like, I forget to, like, write it in the notes part. So, yeah. But it doesn't matter because, like I said, if you're taking the absolute value, it's just going to... You look very uncomfortable. All right, so the next one, slightly different. Use the linear approximation. 1 plus x to the k is approximately, I'm gonna write this as we go, is approximately equal to 1 plus k x to find the approximation for the function f of x for the values of x.
Oh, is it the...
Oh, I see what I did. Okay. I had something really weird written on my paper, so I was like, what is happening? Okay, so for 10, or I guess I should write, that's just the instructions there. So it's 3 parts, or well, 3 separate questions technically under this. So A is f of x is equal to 4 plus 3x to the 1/3. So I want this to look like this 1 plus x to the k. So I need to take something out to give me a 1 right here. Okay, so what I'm going to do, I'm going to take out a 4. And then I'm left with 1 plus 3/4 x all raised to the 1/3. No, not yet. So then the 1/3 goes on both pieces, so 4 to the 1/3.
So that's general then? So then it's just...
No, I'm not. I'm just rules of exponents. And then 1 plus 3/4 x to the 1/3. Hold on, there's a minor issue here. Thinking there's a little bit of a what? Hold on. There's something wrong with this answer in the book, I think. Because they're telling me in the book that the answer is the answer to B, and now I'm really confused. Because there's something I think they have a typo on. I don't know if I'm going to be able to tell it. This is section 5.5. Okay. Huh?
There's way too many typos in this math book for it to be considered playable.
I know, I agree.
It's like so sad.
Like, I'm so confused because in problem 10, this is 100% part A in the book. But in the answers, it's telling me that this is the answer to part B.
Why are you looking at that? Can I bring my locker record jacket?
Yeah, that's fine. And I think they still have, I think there's still a typo in their answer even then. For that. Because see, they say that the answer should be 4 to the 1/3 times 1 plus x over 4 to the 1/3. So I'm like, where'd the 3 go? You know what I'm saying?
Yeah.
Like, I think it's a typo because their whole thing has a typo. But I'm like trying to figure out if I'm missing something. But none of the other problems are like that. Like, none of the other problems did they, like, take out a number, which is why I feel like
Yeah, it might be a typo.
that they don't even have. Out of curiosity, do you have your book handy?
It's in my locker. I can go get it.
Okay, wait, is there one on the shelf over there? Can you just grab it and look and see what the problem... I wonder if the problem is different in the student textbook, and that's why. Giving up?
I was just trying to put my jacket on. It just wasn't working.
Because I'm wondering if the problems are backwards. There was something that I remember finding that to be true last year with one of the problems. Is like it didn't match up with the teacher book, even though it was the same thing. No? It's the same question. Weird. I don't know.
Did it have something to do with the next one? Although if they kept it, I don't know.
Well, the thing is that they like got they've actually gotten rid of the exponent altogether, and that's where I'm confused because their final answer is this.
For part A?
That's their final answer. But that doesn't make sense for the way, because they're on page 239, there's examples just like these, but they like, well, hold on a second. 1 plus negative 1/2. Where did you get that from? I think actually I don't understand why. Hold on. Too many pages to flip between here. I actually think that what they did, based on another example that they have in the book, is that they actually did in this area, is they did like 1 plus 1/3 times 3/4 x, and they got rid of the 3's, because that's what they did in another problem. They like put the exponent in front of this part. Oh, I got it. So see how this is here, and so they're, whatever this power is, they're saying that you can put it in front. And that's what they're doing. That's why. Okay, never mind. We're good now. It makes sense. So, we can do this because of this right here. So, it's still 4 to the 1/3 times 1 plus x to the 4th. Okay. That makes more sense as to what was going on. Because I was like, all the rest of the problems, it just works out where there's like not something like that.
Yeah.
So it's not really an issue, but with this one it is. So.
Then, like, cross-reference.
Yeah, so that's why I was like I was like pulling pieces from different problems and the examples. And the only one that's even remotely similar is a square root problem. So I was like, okay, well, hold on. Let me figure this out. Okay, we got it. So now... make a note of that for next year so that we don't have that issue again, even though they still, whatever. Okay, so then B is f of x equal to the square root of 2 plus x squared. So then thinking about this one as 2 plus x squared to the 1/2. I need to take something out again because I still want it in this form of 1 plus x to the k. So I would actually have 2 times 1 plus 1/2 x squared, all of that to the 1/2. So then we put the 1/2 on each piece, so that would be 2 to the 1/2 times 1 plus, I'm just going to write it this way, x squared over 2 to the 1/2. And really, I think a better way to write it would be like this. That right there is equal to 2 to the 1/2 times 1 plus 1/2 times x squared over 2, I think would be make the most sense to write it this way. So then this is equal to the square root of 2 times 1 plus x squared over 4. And then on the other side, we have the square root of 2 is equal to 1 plus x squared over 2 times 1/2. And I guess what they're trying to say is if you plug in a value and you get an answer, they should be about the same, I think is what they're trying to show here.
So then, can you keep showing one step further and take the square root of that value of the 1 plus x squared over 2, because that's what that is, and then multiply the 2 through?
Well, so it wants it in this form. It wants us to show that this is equal.
Oh, approximately.
So we just need to leave it. Yeah, I mean, so obviously the answers aren't going to be exact, but they'll be very similar in theory if you plug numbers in and check them, is what they're trying to show there. So then,
But they'll be like close.
huh?
But they'll be like really close to each other instead of like being equal to each other.
Yeah. Because in reality, this should be that approximately equal to.
Yeah. Okay. It's like leaving a lot of room for, or if I mess up, if they're close together, right? What problem is this again?
Yeah, 10. So with this one, we just need to rewrite this with the cube root and the exponent. So 1 minus 1 over 2 plus x to the 2/3. So that takes care of the one part because it's 1 plus x raised to the k. So then now we just need to basically put this 2/3 in front. So 1 minus 2/3 times 1 over 2 plus x. So then this equals 1 minus 2 over 6 plus 3x. So there. All right, I think we're going to go ahead and stop there because there's a couple problems that go together on the next thing, so we'll wait and do those together tomorrow. Where? Right here?
Yeah.
So,
Like that whole thing, how we get there.
yeah, so basically, you see how this is 1 plus x to the k? So what they're wanting us to show is that if we put this k value, whatever it is, in front of x, these should be approximately equal.
Okay.
So this k just comes here is all that they're showing you, is that instead of it being on the outside, you're now throwing it inside.
Okay, so that's why.
So that's why we took that power and threw it there.
Got it.
But that's why I was confused, because there's no example problem in the book that shows like that actual step. They just do it. And then I found the one that was like a square root. And then I was like, oh, okay, I see, what they're trying to... I forgot what they wanted us to show, which was why it was confusing. Then I looked and I was like, oh, duh, we're just showing that.